This is my intermediate algebra course. Today we're going to continue to learn the exponent rules. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, we learned these rules on the left page in the previous class, but if you don't want to access your files, you can go ahead and take a picture with your phone. Probably best to take a picture with your phone so that you can look at these while we're doing the problems. You're definitely going to need these in front of you while we do the problems, because you're going to need to name each rule by the Roman numeral. And so in the previous class, we learned these new rules here, the green and the blue rules, and we reviewed whatever that color is, that pink, those pink rules there. And you know, every problem that we did in the previous class required only one rule, but today we're going to do problems that each require more than one rule. And so let's get started here. But before we get started, I want to mention one thing that I didn't really mention in the previous class, and that is when you do these problems, it's best to leave your answer without fraction powers, fraction exponents, or negative powers. Because remember, we learned in the previous class that negative exponents and fraction exponents don't really have a direct meaning. So in my course, I'm not going to allow you to leave your answer with fraction exponents or negative exponents. So as you can see here, it says do not leave your answers with fraction or negative exponents. Okay, so let's do the first problem here. Notice it says these are two rule problems, because we're going to need to use two rules for each problem. So for this problem, we're going to use rule number 1, and I want you to write the Roman numerals in the margin as we did in the previous class. And rule number 1 tells you that if you're multiplying a power by another power, then you just add the exponents. So we get negative 3 plus 3, which is 0. Then we're going to use rule number 7, which tells us that anything raised to the 0 power is just 1. So do you see how we use two rules in one problem? Okay, so let's try another one of these. We're going to use rule number 3, which tells us that if you have a product of two numbers and you raise that product to some exponent, some power, then you take the first number in the product and raise it to that power, and then multiply that by the second number in the product raised to that same power. So 4 squared is 16. And now we have to use rule number 5, which tells us that if you raise some number to a power, or if you raise a power to another power, then you multiply the powers, so, or multiply the exponents, whatever you want to call them. So that's 5 times 2. And then we get 16 times x to the 10th power, and you can just get rid of that dot. I wrote a lot of steps there that you don't really need to write. I'm just writing those so you know exactly what's going on here. All right, so again, we use two rules for each of these problems over here. Okay, so now we're going to use, we're dividing one power by another power, so we just subtract the exponents. But that's rule number 2. So we get x to the 6 minus 5. And then we're going to use, well, first of all, let's simplify. So we have x to the first power. Anything raised to the first power is just equal to that number. And that is rule number 6. All right, so let's do another one here. For this problem, we have a negative exponent, so we have to get rid of that negative exponent immediately. And we're going to use rule number 8. So we're going to bring it down and change the exponent to a positive number. And be aware that this negative here, that doesn't, that doesn't really have anything to do with it. It's not the power. It's in front of the base. It's actually part of the base. So now, in order to figure out what this is, we're going to have to use rule number 9. And rule number 9 tells us that 1/5 power means the 5th root of negative 32. And we don't really, because we have the root there, we don't need the parentheses anymore. And what number times itself 5 times is negative 32? Well, that's just going to be equal to negative 2. And it's traditional to put that negative in front of the, or up level with the fraction symbol. So now I want you to try some problems. And what you're going to notice, you see all these problem sets? I have problem set A, problem set B, problem set C. For each one of these problem sets, the first half of the problem set I'm going to do, and then you're going to do the second half of the problem set. But what you'll notice is that the second half has problems that are very, very similar to the first half. So what I want you to do is use all the problems that I just did with you to do number 5. So go ahead and try number 5, use problems 1 through 4, and when you come back, we'll do it together. Remember to write the Roman numerals in the margin there. All right, we're back. So we're going to use rule number 3. And the reason for that is we have a product of 2 numbers and we're raising it to a power. And so we're going to take the first number and raise it to that power, and then the second number and raise it to that power. And you don't really have to show the dot, but I'm just going to do it. I want to be absolutely sure that you know what's going on here. Negative 2 to the 4th power is 16. And then we're going to use rule number 5, which is if you're raising a power to another power, then you just multiply the powers. So we get 16 times y to the 12th. And again, I'm going to start skipping some of these steps because you don't really need to show the step where you get rid of that dot. All right, so if you got that answer, good job. Go ahead and try number 6. Again, you want to use the problems 1 through 4 to help you. So try number 6, and when you come back, we'll do it together. All right, we're back. So first thing we need to do is get rid of the negative power. We're going to use rule number 8. So we have 1 over 8 to the 1/3 power. And then we're going to use rule number 9. Rule number 9 tells us that 1/3 means the cube root, or 3rd root of 8. So what number times itself 2 times is equal to 8? Well, 2 times 2 times 2. So the answer is 2. Or our final answer is 1/2, but cube root 8 is 2. So if you got that answer, good job. Go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2 because we're dividing powers. When you divide powers, you subtract the exponents, and you get b to the 1st power. But anything raised to the 1st power is just that, whatever the number is, the base, and that is rule number 6. So if you got that answer, good job. Be sure to rectangle your answers. Remember, you always have to rectangle your answers. Okay, so try number 8, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 1. And by the way, there's a lot of different ways to do these problems. So, you're probably used to the way, obviously, that I showed you how to do these problems, but there are some different ways. If you look in a textbook, you might see some different ways of doing these. So that's rule number 1, and 9 plus negative 9 is 0. So now we have to use rule number 7. Anything raised to the 0 power is just 1. So if you got that answer, good job. Okay, on to the next problem set. So now we have a fraction that is raised to some power. And in that situation, you're going to use rule number 4. And rule number 4 tells us that you take the numerator and raise it to that power, and you divide by the denominator raised to that same power. And then we're going to use rule number 5, which tells us that when you have a power raised to another power, you just multiply the powers. Same thing on the bottom. And so we get x to the 12th, x to the 6th, all over y to the 12th. All right. So let's try another one of those. We have a power raised to another power. So we're going to multiply the powers just like we did in the previous problem. That's rule number 5. And 9 times 1/9, that's just going to be 1. And if you don't know why 9 times 1/9 is 1, again, that's just basic arithmetic. You take the whole number, write it, you can write any whole number as over 1, and then you're multiplying by 1/9, so you're just multiplying straight across. When you multiply fractions, you just multiply straight across. 9 times 1 is 9, and 9 times 1 again in the bottom is 9. And of course, 9 over 9 is 1. All right, now again, I hesitate to show you that because that's really something that you should know by now. But a lot of students have deficiencies when they come out of, courses other than mine. But even if you took my course, you may be a little rusty on that. So now x to the 1 power is just x, and that is rule number 6. Now, the reason that I put a star next to number 11 is that notice that the bases of the powers are 5. And in the previous class, we didn't really have a problem quite like that. We had problems like x to the negative 3 over x to the negative 3. Our bases were mostly letters, variables. So in this problem, our bases are just a normal number, 5, but it works the same way. We're going to use rule number 2, which tells us that if you're dividing powers, you just subtract the powers. So we have negative 3 minus negative 3. Be very careful. Be very, very careful because that's going to be a double negative. A lot of times you'll see students write negative 3 minus 3. That's not correct. We're subtracting negative 3 from negative 3. And of course, that's a double negative. So we have negative 3 plus 3. And we get 5 to the 0 power, and anything raised to the 0 power is 1, and that is rule number 7. All right, so let's try another one here. Again, we're using 2 rules for each one of these problems. The difference is, in the previous class, we only used 1 rule for each problem. So now we're going to use rule number 1. When you're multiplying powers, you just add the exponents. And by the way, I just want you to be aware that, you can write a to the 5 minus 7. You don't need to write the plus and the parentheses and all that, but I'm just doing that because it's easier to understand, what's going on. You're adding the powers, so then we get 5 plus negative 7 is negative 2. But now we have to use rule number 8 to get rid of that negative power. We're not allowed to leave our answer with a negative power. So we get 1 over a to the 2nd power. All right, so now it's your turn. Try number 13 and use the previous 4 problems that we did to help you. When you come back, we'll do it together. All right, we're back. And by the way, if you didn't write the Roman numerals, remember, you got to write those in the margin. So we have a power raised to another power, so we're going to multiply the exponents. That's rule number 5. So 1/2 times 2 is just 1. And anything raised to the 1 power is just whatever that number is, and that's rule number 6. So if you got that answer, good job. All right, try number 14. Use the first 4 problems, 9 through 12, to help you, and when you come back, we'll do it together. All right, we're back. So we're going to add the powers because we're multiplying powers, and that's rule number 1. Add those up and you get 10 to the negative 4th power. But we're not allowed to leave our answer with a negative power, so we have to use rule number 8, which tells us that we get 1 over 10 to the 4th power. And I also should mention that you always want to simplify your answer if you can. Obviously 10 to the 4th power, that's pretty easy. You just write a 1 with 4 zeros. Whenever you raise something to whenever you raise 10 to some power, Whatever the power is, that's just how many zeros. All right, so if you got that answer, good job. If you wrote that as the answer, that's good. No problem whatsoever. Except I'm going to require you to write it like this because, again, it's if you can simplify, go ahead and simplify. Okay, on to the next problem, number 15. Again, use numbers 9 through 12 to help you. And when you come back, we'll do it together. All right, we're back. So we have a fraction raised to a power, and rule number 4 tells us that you take the numerator and raise it to that power, and divide all that by the denominator raised to the same power. But now we have to use rule number 5 because we're raising powers to other powers, so we have a to the 3 times 2 over b to the 4 times 2. So we get a to the 6th power over b to the 8th power. And there you go. So if you got that answer, good job. All right, go ahead and try number 16. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2 because we're dividing powers. And we end up with y to the negative 2 minus negative 2. That's a double negative, so we get y to the negative 2 plus 2. And if we add those up, we get y to the 0 power. But anything raised to the 0 power is just equal to 1. And that is rule number 7. So we end up with 1. So if you got 1, good job. Okay, now let's go to problem set C, the next problem set here. So let's do some of these problems together. We're raising a power to another power, so we end up with 27 to the 2 times 1/3 power. That's rule number 5. Now we just multiply. 2 times 1/3 is 2/3. Again, if you're rusty on multiplying whole numbers by fractions, just go back to my arithmetic course. And so now I'm just going to, 2, you can just write it as 2 over 1, and then multiply by 1/3, multiply straight across, and you get 2 over 3. So now we have to use rule number 10, because remember, we cannot leave our answer with fraction powers because this doesn't have any meaning. If I say, give me 2 to the negative 2 power of the pizza, you're going to be really confused by that. Well, you may not be confused, but most people in the world would be confused. They're not going to know that that's equal to 1/4. You see, because this has no direct meaning. So we have to translate this. It doesn't have any direct meaning. So rule number 10 tells us that that's equal to the cube root of 27, all raised to the 2nd power. The denominator is always the index of the root. And the numerator is always what we raise the whole expression to. So we know cube root 27, that's just equal to 3. And you don't really need the parentheses, but I'm just going to keep them so you can see what exactly is going on here. And then that's just equal to 3 to the 2nd power. Again, this is, way too many steps. You don't need this many steps, but I'm just being very careful to show you what's going on here. And 3 to the 2nd power, that's just equal to 9. So let me make a little more room. 9, and let's go to the next problem. So now we have powers. We're dividing powers. That's rule number 2. So we get b to the 3 minus 9, which is equal to b to the negative 6. But now we have a negative power. We're not allowed to leave our answers with negative powers. So we have 1 over b to the 6th power. And there you go. All right. So number 19, we have a product of two numbers that's raised to a power. So you're going to use rule number 3. So we take the first number in the product and raise it to that power, and then we multiply that by the second number in the product raised to the same power. And now we're going to use rule number 5 because we're raising a power to another power. So we have a to the 2 times 3. And I'm just going to leave off the dot there because it's going to get kind of confusing if we have dots all over the place. And then we end up with a to the 6th power times b to the 18th power, and that's it. So let's try number 20. We're multiplying powers, so that's rule number 1. We're going to add the exponents. So we have 4 to the 3/4 plus 1/7. But notice now we have fractions. We have to add these fractions, but we can't add fractions unless we have a common denominator. So I'm going to multiply both sides of this fraction by 7 to get 21 over 28. And I'm going to multiply both sides of this fraction by 4 to get 4 over 28. Now we have a common denominator, so now we can add them up. 21 over 28 plus 4 over 28 equals 25 over 28. You just add 4 and 21 to get that numerator. So at this point, I don't think we can reduce that fraction. So we're just going to use rule. Remember, we can't leave our answer as or with a fraction exponent. So now we're going to have to use rule number 10. So that becomes the 28th root of 4 all raised to the 25th power. So now it's time for you to try. I want you to try 21 and use numbers 17 through 20 to help you. And when you come back, we'll do it together. All right, we're back. So we're raising a power to another power. So we're going to use rule number 5, which tells us to multiply the powers. And 5 times 1/6 is just 5/6. But we can't leave our answer with a fraction exponent, so we're going to have to use rule number 10, which tells us that that equals the 6th root of b raised to the 5th power. All right. So if you got that answer, good job. Try number 22, and when you come back, we'll do it together. All right, we're back. So we're multiplying 2 powers, which means we have to add the exponent. So we get 7 to the 5/8 plus 3/8. And now there's good news because these fractions already have a common denominator. So we can just add them immediately. 5/8 plus 3/8 is 8/8. 5 plus 3 is 8. Now 8/8 is the same thing as 1. So now we can use rule number 6, which tells us anything raised to the 1 power is just whatever that number is, that base. So if you got that answer, good job. Try number 23, and when you come back, we'll do it together. All right, we're back. So we're dividing powers, which means we have to use rule number 2. We're going to subtract the exponents. But now we have a negative power. So we're going to have to use rule number 8, which tells us that that goes below and the exponent changes to a positive number. Now, don't leave your answer like this. If you can simplify, simplify. So 8 squared is just 64, so you'd never want to leave your answer as 1 over 8 squared. Why would you do that when you can write 1 over 64? But if you got that answer, good job. If you didn't get that answer, just figure out what you did wrong and fix your mistake. Okay, on to number 24. Go ahead and try number 24. Again, use problems 17 through 20 to help you. And when you come back, we'll do it together. All right, we're back. So we have a product here raised to some power. And rule number 3 tells us that you take the first number in the product and raise it to that power. And you multiply by the second number in the product raised to the same power. Now we have powers raised to other powers, so we're going to have to use rule number 5, which tells us to multiply the powers. So our final answer, let me make some more room here. Our final answer is going to be x to the 16th power times y to the 32nd power. So if you got that answer, good job. Okay, on to problem set D. So let's try some more of these problems together. So we're raising a power to another power, so that's going to be rule number 5. Okay, and we just multiply the exponents, and 1/2 times 1/3. Again, I'm going to tell you again, you should already know this by now. You learned this in arithmetic. But when you multiply fractions, you just multiply the numerators. 1 times 1 is 1. Multiply the denominators. 2 times 3 is 6. So 1/6. So we get x to the 1/6 power. Okay, now that is rule, well, that's rule number 5. But now we're going to have to use rule number 9, which tells us that that's going to be the 6th root of x. And the reason we had to do that is because we're not allowed to leave our answers with fraction exponents, remember. Okay, on to number 26. We have a fraction raised to a power, so we're going to use rule number 4, which tells us that you take the numerator and raise it to that power, and you divide that by the denominator raised to that same power. Oh, whoops, I'm sorry, that should be a -4. -4. Now keep in mind, you can actually get rid of this negative first, but that would complicate the problem significantly. So we're just going to use rule number 4 first instead of using rule number 8. Okay, so now we're going to use rule number 5, which tells us if you're raising a power to another power, you just multiply the powers. So we have -2 times -4. And notice that I'm choosing not to use dots. I'm choosing to use parentheses for the multiplication, because whenever you have a negative sign, it becomes very handy to use parentheses, or else things are going to get weird. You're not really allowed to write -2 dot -4, because that's just, the notation can be misleading. So now we multiply, and we get b to the -2 times -4 is +8, and -3 times -4 is +12. So there you go. All right, so let's try the next one here. We're multiplying powers, so that's rule number 1. A to the 3 plus -2, we're adding the exponents, and then we get a to the first power. But you know by rule number 6 that anything raised to the first power is just whatever that number is. It doesn't really change it. Okay, let's try one more of these. We're dividing powers. That's rule number 2. So we have to subtract the exponents, but notice that these fractions don't have a common denominator. So we have to find a lowest common denominator. So we're going to multiply both sides of this fraction by 2 to get 2/12. And now we have a common denominator. So now we just subtract 5/12 minus 2/12 is 3/12. And before we do anything at this point, you might be tempted to use rule number 10 at this point, you see, but we don't want to do that yet, because remember, whenever you have a fraction that can be reduced, you always reduce it. At least almost always. There may be some situations where you wouldn't want to. For example, here you don't want to reduce that, because that would be going backwards to 1/6. So now that simplifies to 1/4. Dividing both these numbers by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So now b to the 1/4, that's just, we're going to use rule number 9, which tells us that that's equal to the 4th root of b. Let me just get a little more room here. So that's the 4th root of b. All right. So now it's time for you to try. Attempt number 29. Use problems 25 through 28 to help you. And when you come back, we'll do it together. All right, we're back. So we're dividing powers. So we have to use, well, actually, we're raising a fraction to another power, so we're going to use rule number 4. And that tells us that you take the numerator and raise it to the power, and then divide by the denominator raised to that same power. Whoops, I'm sorry, I don't know why, but I keep forgetting to write the negatives when we do that. Okay, so now we're raising powers to other powers. That's going to be rule number 5. So we have x to the negative 4 times negative 2 over y to the negative 8 times negative 2. And multiplying those, we get x to the 8th power over y to the 16th power. So if you got that answer, good job. Now, the reason that I put a star next to number 30 is that in the previous class, I don't think we had a problem quite like this where the bases were actual numbers. You know, we would have problems where it would be x to the negative 7 times x to the 8. And of course, you know, that's going to be rule number 1. You add the powers. But now we have actual numbers, 3 to the negative 7 times 3 to the 8. But it works the same way. You know, you just keep the 3, and then you add the powers. So give it your best shot. And if you get stuck, that's okay. But go ahead and try number 30. And when you come back, we'll do it together. All right, we're back. So this is going to be rule number 1. When you multiply powers, you just add the exponents. And negative 7 plus 8 is 1. And anything raised to the 1 power is just whatever that number is, and that is rule number 6. All right, so I want you to try number 31. And when you come back, we'll do it together. All right, we're back. So we're raising a power to another power, so we're going to multiply the exponents. That's rule number 5. And 1/3 times 3/2, that's just equal to 1/2. Now we can't leave our answer with a fraction power, so we have to use rule number 9, which tells us that that becomes the square root of 4. Now, you could put a 2 here, but again, it's not really proper notation to do that. I mean, you could do it, it'd probably be okay, but you never write the index when the index is 2. So now the square root of 4 is 2. So if you got that answer, good job. All right, try number 32, and when you come back, we'll do it together. All right, we're back. So when you're dividing powers, you just subtract the exponents. That's rule number 2. So we have x to the 3/4 minus 1/6. And the problem is we don't have a common denominator, so we have to multiply both sides of this fraction by 3 to get 9/12, and both sides of this fraction by 2 to get 2/12, and now we have a common denominator, 12. So 9/12 minus 2/12 is 7/12. And we can't leave our answers with a fraction exponent, so we have to use rule number 10, which tells us that that equals the 12th root of x, all raised to the 7th power. And let me get a little more room here. And of course, we need to rectangle our final answer. Okay, so let's try another problem set here. So let's do these together. So we're raising a power to another power, and at this point you might be thinking, you know, okay, I get the point, I've seen enough of these. Well, you have not seen enough of these. You need to do problem after problem after problem after problem, and you need repetition, repetition, repetition. A lot of students will say, well, this is boring and I don't want to do this anymore. Well, you know, the only way to learn math is to do tons and tons of practice. You will not learn the math unless you do many, many practice problems. Many more than you're going to want to do. That's why math is difficult. You can't learn fluency in this language unless you do problem after problem after problem. So if you're a homeschool parent or a teacher listening to this or a student, whoever, you need to understand you will not learn this material unless you do at least the number of problems that I'm giving you. You know, it's like if you want to learn the English language but you don't really want to speak it much. Well, you're not going to learn fluency unless you actually speak the language. That's what you learn in foreign language courses. You never learn the language. You never learn fluency in the language unless you actually, you know, spend time around people that speak the language. And that's just the way it is. Well, it's the same way with math. You're not going to learn the language unless you do problem after problem after problem after problem. So we're going to use rule number 5. raising a power to another power, we just multiply the exponents. And it's very important to use parentheses there because we don't want to confuse ourselves. And negative 3/4 times negative 4/3, if you do the math on that, it's just going to end up being 1. Just multiply the numerators, multiply the denominators, you get 12 over 12, which is 1. And anything raised to the 1 power is just whatever that number is. That is rule number 6. So I also want you to understand that not every one of these problems is exactly the same. They have very minor differences. I'm not just choosing these numbers randomly. So every single one of these problems is teaching you something new. All right, so now we're going to use rule number 1. And again, we don't have variable bases, but still the bases are the same. So we can use rule number 1. We're going to add the exponents because we're multiplying powers. And now this here, again, a lot of students get confused when you're adding a whole number with a fraction. Technically, you're supposed to know this already, but the whole number you can write as over 1. And now we can kind of see, what we have to do. We have to get a common denominator, so we're going to have to multiply both sides of this fraction by 3. 3 times 3 is 9, and 3 times 1 is 3. And now you can see that we have a common denominator. So 9/3 plus negative 7/3 is 2/3. So let's see. I don't know if I can really show that math. I don't know. I really doubt if I have enough room. So that becomes 9/3. Some of these problems I planned on showing the work, other problems I planned on not showing it. And yeah, there's no way that I'm going to be able to show that. So we get to a certain point in math where you just can't show every single step. You gotta skip. So this is a perfect example of that. You're required to know how to do this. So at some point your intermediate algebra teachers are not going to tolerate stopping and trying to figure that out. You should know how to do that by now. Well, I mean, it's okay to stop and do this. I'm not saying you can't, stop and think about that. I'm just saying that teachers are not going to, go over this. They're not going to, show you how to do that because it's assumed that you already know. So now we get 125 to the 2/3 power, and now we're going to have to use rule number 10, which tells us that equals the cube root of 125, all raised to the 2nd power. And the cube root of 125, what number times itself 3 times is equal to 125? Well, it's 5 times 5 times 5. So that's going to be 5 to the 2nd power. And 5 to the 2nd power is just 25. Okay. All right, let's try another one of these. We're going to use rule number 2 because we're dividing powers, which means we're going to subtract the exponents. And we get a double negative there, so we have b to the negative 7/9 plus 16/9. And good thing we have a common denominator. Negative 7 plus 16 is 9/9. Or negative 7 plus 16 is just 9, and we have 9/9, which becomes b to the 1st power, which is b. We used rule number 6 to say that b to the 1st power is b. All right, so I don't remember why I put a star there, so I guess you can just ignore that. So now we have a number that's raised, our power raised to another power, so we're going to use rule number 5. So I multiply those. 3 times negative 1 is negative 3. But now remember, we can't leave our answer with a negative exponent. So we're going to have to use rule number 8, which deals with negative exponents. That tells us it becomes 1 over 3 to the 3rd power. Change the power to a positive. And then we don't want to leave our answer like that. Remember, if you can simplify an expression in math, always simplify it. Okay, so now it's time for you to try. I want you to try number 37. Use problems 33 through 36 to help you. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2, which tells us if you're dividing powers, you subtract the exponents. And 7/6 minus 1/6 is 6/6. 6/6 is just 1. And anything raised to the 1 power is just that number. It doesn't really do anything to the number. That's rule number 6. So if you got that one right, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. So try number 38. Again, use problems 33 through 36 to help you. And when you come back, we'll do it together. All right, we're back. So we're multiplying powers. So we're going to use rule number 1, which tells us to add the exponents. And again, we don't, this is something you should be able to do. You learn that in arithmetic. So negative 7/5 plus 2 is 3/5. And you might wonder, well, how do I do that in my head? Well, when you get practice with this stuff, you're going to learn how to do it in your head really quickly. Right now, you might have to do it on a separate piece of paper. That's completely fine. But when you get into upper mathematics, you're actually going to do that really quickly in your head. It may not seem like it now, but trust me, when you go up into these bigger courses, you're going to do that stuff. Okay, so now let's see here. We need to use rule number 10. And so we get the 5th root of a raised to the 3rd power. And that's the final answer. So if you got that answer, good job. All right, I want you to try number 39. And when you come back, we'll do it together. All right, we're back. So we're raising a power to another power. That's rule number 5. And you take the powers, or the exponents, and you multiply them. Negative 1 times 2 is negative 2. And remember, we can't leave our answer with a negative exponent. We have to use rule number 8, which tells us that that's equal to 1 over 7 to the 2nd power. But remember, you have to simplify your answer if at all possible. So we get 1 over 49. If you got that answer, good job. Try number 40. And when you come back, we'll do it together. All right, we're back. You're raising a power to another power. So you multiply the exponents. And 4 7s times 7 7ths is just 1. And anything raised to the 1st power, that's just the original number, or the base. So that's rule number 5 and rule number 6. So if you got those answers, or that answer, good job. Okay, on to the next problem set. And again, I need to keep reminding you over and over and over again, a lot of students will get angry. They'll get angry and they'll say, I've seen these before. Well, I understand that, but again, there's 2 reasons that we keep doing these problems over and over again. Number 1, there's slight differences between every problem. You know, a lot of students, they get this attitude and they say, well, I don't want to do this anymore. I've got it. You don't have it. You don't got it. I will tell you when you have enough problems. Okay, the reason I wrote all these problems is to help you learn fluency. And, again, there's 2 reasons. Number 1, we have to do many, many problems to learn fluency. And the second reason is that there's slight differences in these problems. So don't be one of these students who kind of just bails and says, well, I have enough problems to know this stuff. You don't have enough problems. Okay, you'll have enough problems when I tell you that you have enough problems. All right, remember, you only do 2 videos per week and 2 homework assignments. That's it. So I don't want to hear any complaining. All right, so number 41, let's do this one together. Obviously, it's rule number 5. So we have x to the 2nd power times negative 2. When you're raising a power to another power, you just multiply the powers, and we get x to the negative 4 power. And, of course, we have to use rule number 8 to get rid of that negative power. We cannot leave our answer with a negative exponent. All right, so let's try the next one here. We're multiplying powers. And so when you do that, you add the exponents. And 3/7 plus 4/7 is 7/7. But you know 7 out of 7, that would just be 1. And anything raised to the 1 power is just whatever that number is. That is rule number 6. Okay, we're using rule number 1 again because we're multiplying powers. And so when you multiply powers, you just add the exponents. And when you do that, you have luckily we have the same denominator. They have a common denominator, so you just add, -2 plus 2, which is 0. So you get 0 over 5. But remember, 0 over 5 is just 0. You don't really have to write this intermediate step here. I'm just showing you that. So anything raised to the 0 power is just 1. So that's rule number 7. All right. On to number 44. So we have a product. In fact, we have 3 numbers in there. But it doesn't matter how many numbers you have in there. You just raise each one to whatever the power is. And so this is rule number 3. And it tells us that you take each number in the product and you raise it to that power. And of course you multiply all the resulting numbers. Now we have to use rule number 5. And we get x to the 6 times 7 times y to the 2 times 7 times z to the 3 times 7. And then we just end up with x to the 42nd power times y to the 14th power times z to the 21st power. There you go. All right. Now for this problem, there's multiple ways to do this. You could use rule number 3 and say 8 to the -2 power times x to the -2 power, but I think it's going to be easier to understand if we actually use rule number 8 first. Like I said, there's many different ways to do these problems, so I'm showing you what I believe is the easiest way to do them. And because this is very important to understand that because this is in parentheses, that means you're raising this whole thing to the -2 power. And if you use rule number 8, then that means you drop everything down, the 8 and the x, and change the exponent to a positive number. Again, that's rule number 8. That's how you deal with negative exponents. So now we have to use rule number 3 because we have a product raised to some power. And rule number 3 tells us that you take the first number and raise it to that power and then multiply that by the second number raised to the same power. 8 to the 2nd power is 64, and that's it. That's the answer. And it probably makes sense to put that 1 in the center. All right, so I want you to use problems 41 through 45 to help you with 46. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 3. Because we have a product of a bunch of numbers, and we're raising that to some power. So we have to take the first number, raise it to the power, then multiply by the second number raised to that same power, and then multiply it by the third number raised to that same power. Now we have powers raised to other powers, so we have to use rule number 5. So that becomes a to the 2 times 4 power times b to the 3 times 4 power times c to the 4th power. And that becomes a to the 8th times b to the 12th times c to the 4th. So if you got that answer, good job. All right, I want you to try number 47. Use problems 41 through 45 to help you, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 1 because we're multiplying powers. And rule number 1 tells us to add the exponents. And the problem is we don't have a common denominator, so we're going to have to multiply both sides of this fraction by 3 to get 3 over 6. And 1/6 plus 3/6 is 4/6. Now, at that point, you might be tempted to go ahead and write, the 6th root of x to the 4th, and that would not be wrong. But the problem is this fraction here is not reduced. You want to reduce it first. So if you forgot to do that, that's okay. But you always need to reduce fractions if you can. So now we're going to use rule number 10, which tells us that becomes the cube root of x raised to the 2nd power. Okay, try number 48, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 5 again, because we're raising a power to another power. And you can use a dot if you want. You can also use parentheses. If this were a negative, then you'd have to use parentheses. But if this is a negative, it's not really necessary. So now we multiply, we get -6, but remember we can't leave our answer with a negative power, so you have to use rule number 8. So now we get 1 over 2 to the 6th power. And 2 to the 6th power, that's kind of a big number, but you can manage it. That's just going to be 64. So if you got that answer, good job. All right, try number 49, and when you come back, we'll do it together. All right, we're back. So we're multiplying powers, so you're going to have to use rule number 1. So we get c to the 1/4 power plus -1/4. And 1/4 plus -1/4 is obviously 0, and then anything raised to the 0 power is just 1. And that is rule number 7. All right. So by doing these problems, you're memorizing the rules, and you're getting fluency, and you're learning all the different variations that you can see. So try number 50. Remember, you want to use rule number 8 first. You want to bring all this under 1 and change this to a positive exponent, because that's just the easiest way to do it. So try number 50. Use number 45 as a reference, and when you come back, we'll do it together. All right, we're back. So again, we're going to use rule number 8 first. It may look strange, but that's the easiest way to do it. And by the way, when you use rule number 8, don't get rid of the parentheses. Don't write that to the 3rd power, because now 3 is technically not raised to the 3rd power. The whole thing has to be raised to the 3rd power. So now we're going to use rule number 3, because we have a product that is raised to some power. And that tells us to take the first number and raise it to that power, and then multiply that by the second number raised to the same power. And 3 to the 3rd power is 27, and that's all you can do. So if you got that answer, good job. Let me write that 27 a little better. All right, so on to the next problems here. Now we're going to 3 rule problems. So in the first exponent class, we learned problems that required 1 rule. We just did a lot of problems that require 2 rules. Now we're going to go to problems that require 3 rules. So we have a power raised to another power. So we use rule number 5, which tells us that we multiply the exponents. And now again, you can write the whole number as over 1. So now we're just multiplying fractions. -3 times 1 is -3. 1 times 4 is 4. So we get -3/4. So then we end up with 16 to the -3/4. But we have 2 problems. You see, we have 2 problems. One problem is that we have a negative exponent, and the other problem is we have a fraction exponent. So we have to take care of both those problems. So you might wonder, well, what do we do first? Do we take care of the negative, or do we take care of the fraction, or get rid of those? Well, we're going to deal with the negative first. We're going to use rule number 8. And let me make that a better Roman numeral there. So we're going to bring it all down using a positive exponent, and now we're going to use rule number 10 because we can't have our answer. We're going to we dealt with the negative, but now we have to deal with the fraction exponent. So that becomes the cube root of 16. Whoops, I'm sorry, the fourth root of 16. All raised to the third power. So here we used rule number 5, and here we used rule number 8, and here we used rule number 10. So we used 3 rules. So now at that point we just simplify. I'm going to go ahead and move this stuff over a little bit because I'm running out of room. So the fourth root of 16, what number times itself 4 times is equal to 16? And the answer is 2. So we have 1 over 2 to the third power, which is 1 over 8. There you go. So again, we use 3 rules. Let's try another problem that requires 3 rules. So the first thing we're going to do is we're going to combine these because they have the same base. You cannot combine the green powers with the blue power because the blue power has a different base, you see. So we're going to use rule number 1, which tells us that that's a to the 3 plus 6 power times y squared all raised to the 6th. And 3 plus 6 is 9, so we have a to the 9th power times y to the 2nd power raised to the 6th. Okay, now we have a product raised to some power. So we have to use rule number 3. All right, rule number 3 tells us that you take the first number in the product and raise it to that power, and then multiply by the second number in the product and raise to the same power. So, but now we have to use rule number 5 because we have powers raised to other powers. So that becomes a to the 9 times 6 times y to the 2 times 6. And our final answer is a to the 54th power times y to the 12th power. All right. So again, we used more than one rule, or we used 3 rules actually in that problem. Okay, so on to 53. So the first thing, you know, we're multiplying powers. You see, we have 1 power here. Well, technically it's not really a power, but we want to use rule number 1. The reason it's not a power is because there is no exponent. But we want to use rule number 1, but we can't really do that until we first use rule number 6. But keep in mind that we're going backwards with rule number 6. Rule number 6 says anything to the 1 power is equal to just the base, you know, but we can also go backwards. We can say that x is equal to x to the 1 power. That's what we're going to do here. And I know what you may be thinking. You may be thinking, you know, that's kind of weird. We're going backwards, and it is weird, but you have to go in both directions for, you know, all these equations in certain situations. So we're now going to rewrite that as x to the 1 power. And now we can use rule number 1 because we have the same base in the middle part. Here we have the same base inside there. We can combine those with rule number 1, which tells us if you're multiplying powers, you just add the exponents. And so we add those exponents and we get x to the 4th power raised to the 4th power. But now we have a power raised to another power, so we have to use rule number 5. So that's going to be x to the 4 times 4, which is equal to x to the 16th power. So again, we're using 3 rules for each one of these problems. So let's try one more of these before you try one on your own. Now we're going to use rule number 2 to combine these because we're dividing these powers. But keep in mind we cannot combine the green with the blue. Why? Well, because they don't have the same base, you see. So we're going to use rule number 2, dividing those x powers we have, let's just rewrite the y to the fourth. Then we have x to the 5 minus 3. Rule number 2 tells us that we can subtract the exponents when we're dividing powers. So then we end up with y to the 4th power times x to the 2nd power raised to the 7th. Now we have a product raised to a power, so we're going to have to use rule number 3, which tells us to take the first number in the product and raise it to that power, and then multiply by the second number in the product raised to that same power. But now we have to use rule number 5, because we have powers raised to other powers. So now we have y to the 4th power times 7 times x to the 2nd power times 7, and we get y to the 28th power times x to the 14th power. So those were 4 examples where you actually need to use 3 rules in one problem. Now I want you to understand that when you get to upper math courses, you're not going to have to write these rules. You're probably getting tired of having to write those rules over and over again. But we're just doing that to help you see what rules are being used, because a lot of times teachers will do a lot of operations and they won't really show you what the rule was, and it can be hopelessly confusing sometimes. So I want you to write these rule numbers even if you don't want to. So let's try number 55. Or you try number 55 and use problems 51 through 54 to help you. And when you come back, we'll do it together. All right, we're back. So we're going to combine these powers because they have the same base. So that is rule number 1. So we have, we're going to add the exponents. That's what rule number 1 tells us to do. And so we get b to the 5th power. And now we have a product raised to some power, so that's rule number 3. So we get x, we take the first number in the product and raise it to that power, and then multiply by the second number in the product and raise it to the same power. But now we have powers raised to other powers, so that's rule number 5. And we get x to the 4 times 5 power times b to the 5 times 5 power. And that simplifies to x to the 20th power times b to the 25th power. So if you got those answers, or that answer, good job. All right, so I want you to try 56. And remember to write those rules in the margin. And again, use 51 through 54 to help you. And when you come back, we'll do it together. All right, we're back. So we want to use rule number 1, but we can't use rule number 1 until we use rule number 6, which tells us that any number can be written as, or written with a 1 exponent pretty much. So we're changing b to b to the 1st power. And now we're multiplying powers, so we're just going to add the powers, or the exponents, whatever you want to call them. Again, that word exponent can be interchanged with the power. And so we get b to the 9th power raised to the 5th power. And also we used rule number 1 there when we added the exponents. So now we're going to use rule number 5 to get b to the 9 times 5 power, which is equal to b to the 45th power. And that was rule number 5. So if you got that answer, good job. Try number 57, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 5 first, because when you have a power raised to another power, you want to multiply the exponents. And we get 27 to the negative 2/3 power. Okay, but remember, you're not allowed to leave your answer with negative powers, and also you're not allowed to leave your answers with fraction powers. So what do we deal with first, the negative or the fraction? Well, we always deal with the negative first. Actually, not always. Sometimes you can. I mean, we had a negative exponent here, but we didn't deal with that first. We used rule number 5. So you're just gonna you're gonna know by experience what to do. So let's now get rid of the negative exponent by using rule number 8. So that equals 1 over 27 to the 2/3 power. And now we have to use rule number 10. And rule number 10 tells us that equals 1 over the cube root of 27 raised to the 2nd power. And I think I'm going to bring this down. So the cube root of 27, that's just going to be equal to 3. And 3 to the 2nd power is equal to 9. So our final answer is 1/9. And I guess I'll put this up here so we have more room. All right, so I want you to try 58. I put a little star here because I thought this problem is a little different than the one we did over here. And the difference, between this problem here in blue and this problem in green is that over here the fraction is going to remain. But over here the fraction goes away, and that's because there's more. Well, see, the x squared here is on the bottom, whereas the y to the 4th is in the top here. So that's going to change things, but give it your best try. And when you come back, we'll do number 58 together. All right, we're back. So again, this is going to be slightly different from the example problem we did in the previous 4 problems, or the 4 problems we did in this problem set. So first we're going to use rule number 2 because we're going to subtract, or we're dividing those powers. But just keep in mind that x squared, that stays in the denominator. All right? And instead of 1, it's going to be y to the 6 minus 2. Again, I know that was kind of weird what I did there. But there's more y's in the top than the bottom, so our y's are going to end up in the top. And the x squared, again, the x squared is not going anywhere. That's not affected by anything we did with that rule number 2. So now we have y to the 4th power over x to the 2nd power, all raised to the 10th power. And now we're going to have to use rule number 4 because we have a fraction raised to a power. So you take the numerator of the fraction and raise it to that power, and then you divide by the denominator of the fraction raised to the same power. So now we have powers raised to other powers, so we're going to use rule number 5. And we end up with y to the 4th power times 10 over x to the 2nd power times 10. And let me make these expressions a little smaller. And of course, the final answer is going to be y to the 40th over x to the 20th. Now keep in mind that we cannot simplify that because the bases are different. This y here and the x, they're different bases, so we cannot combine them. So if you got that answer, good job. That was kind of a challenge problem. Okay, on to problem set H. Again, we're doing 3 rule problems. So let's do these together. So we're multiplying powers, but notice how these A powers are not next to each other, but that's okay. Because of the commutative rule of multiplication, we can just switch the order, and we can put those together. So we have a to the negative 5th plus 5 times b to the 5th, all raised to the 6th power. And negative 5 plus 5 is obviously 0, so we have a to the 0 power times b to the 5th raised to the 6th. And now we know anything raised to the 0 power is just 1. That's rule number 7. So then we end up with 1 times b to the 5th power raised to the 6th power. And 1 times b to the 5th power, well, that's just going to be b to the 5th power. Multiplying by 1 doesn't do anything. And now we have a power raised to another power. So we have to use rule number 5. And that becomes b to the 5th power times 6, which is b to the 30th, and you're done. All right. So let's try another one of these. First, we're going to use rule number 1 to simplify the inner part. So we have a to the 7th plus negative 6, all raised to the 1/4. And if you add those together, 7 plus negative 6 is 1. So we have a to the 1st power, all raised to the 1/4 power. Then we're going to use rule number 5 because we have a power raised to another power, and that tells us to multiply the power. So we have a to the 1st power, or a to the 1 times 1/4 power. And, you know, by the way, there's, you could use rule number 6 here first, and then use rule number 9. But I chose to use rule number 5 first, and then we're going to use rule number 9. I think that's just easier to understand. So 1 times 1/4 is 1/4. And then using rule number 9, we get the 4th root of a. All right, so let's do a couple more of these before you try one on your own. So now we're going to use rule number 4 because you're taking a fraction and raising it to a power. So you take the numerator of the fraction and raise it to that power, and divide by the denominator of the fraction raised to that same power. But we have powers raised to other powers, so you're going to have to use rule number 5. So that becomes x to the 6 times 1/6 over y to the 6 times 1/6. So 6 times 1/6 is just 1. And 6 times 1/6 again is 1. So now we have numbers raised to the 1st power. So if we use rule number 6, that tells us that we just get x over y. Anything raised to the 1 power just doesn't change. Okay, on to number 62. We're going to use rule number 2, and that tells us to subtract the exponents when you're dividing powers. And so then we get c to the 0 power. And anything raised to the 0 power is 1. That's rule number 7. So we get b times 1 raised to the 3/8. And b times 1 is just b, obviously. And to be honest with you, you don't really need, you know, those parentheses anymore. So we can just get rid of those, and you don't really have to write that step. And now we're going to use rule number 10, which tells us that that fraction power is going to be the 8th root of b, all raised to the 3rd power. Okay, so again, you're not allowed to have negative exponents or fraction exponents in your final answer. So I want you to use numbers 59 through 62 to do 63. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2 to subtract the exponents. And that becomes a to the 0. And anything raised to the 0 power, rule number 7 tells us that that's just equal to 1. So we get 1 times b raised to the 2/7. And then 1 times b is just b. And you don't really need to write the parentheses. I guess I'll probably just do it. I just want you to be clear or certain what's going on. So now we can get rid of the parentheses. And that just becomes the 7th root of b raised to the 2nd power. So if you got that answer, good job. Whoops, I forgot to write rule number 10. All right, try number 64. Again, you can use numbers 59 through 62 to help you. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 1 because we're multiplying powers. So we have 3 to the negative 7 plus 8 power raised to the 1/5. And that becomes negative 7 plus 8 is 1. Now again, at this point, you could use rule 6 first, but I'm just going to use rule 5. I think that would be easier to understand. Raising a power to another power, you just multiply the exponents. And 1 times 1/5 is just 1/5. And then we're going to use rule number 9. We can't leave our answer with a fraction power, so that becomes the 5th root of 3. All right. So I'm going to write that a little bigger. So if you got that answer, good job. Okay, try number 65, and when you come back, we'll do it together. All right, we're back. So we're going to combine those x's. That's rule number 1. So we have x to the 4 plus negative 4 power times y squared, all raised to the 2nd power. And so we get x to the 0 power. And anything raised to the 0 power is just 1. That's rule number 6. Whoops, that's rule number 7 actually. And 1 times y squared is just y squared. And now we're going to use rule number 5 because we're raising a power to another power, so that tells us that we multiply the powers and we get y to the 4th power. So if you got that answer, good job. Go ahead and try number 66, and when you come back, we'll do it together. All right, we're back. So we're raising a fraction to a power, so we're going to use rule number 4. We take the numerator and raise it to that power. And then divide the denominator raised to that same power. But then we have powers raised to other powers, so we have to use rule number 5, which tells us that that's a to the 1/4 times 4 over b to the 1/4 times 4. And 1/4 times 4 is 1. And now we're going to, anything raised to the 1 power is just, the whatever the base is. So that's rule number 6. All right, so if you got those answers, good job. Now let's go on to one more of these problem sets before we do the last thing that we're going to do today. Let's do these problems together. So this problem is different because we have x's that we can combine, but we also have y's that we can combine. So we're going to use rule number 2, dividing powers, but we're going to do it with both x and y. So subtracting the exponents for x, we get that. Then we have to multiply by y to the 8 minus 5. And of course all that is still raised to the 3rd power. So I know that seems kind of a weird problem. Then we get x to the 4th times y to the 3rd raised to the 3rd. And now we're going to use rule number 3 because we have a product raised to a power. So we take the first number in the product and raise it to that power, and then multiply that by the second number in the product raised to the power. But now we have powers raised to other powers, so we use rule number 5, which tells us to multiply the powers. And we end up with x to the 12th power times y to the 9th power. All right. So let's try another one of these. So remember, in this situation, you want to use rule number 8 first. You don't have to do it that way, but that's going to be the easiest way. So we turn that into a positive exponent with rule 8. And now we have a product raised to a power. So we're going to have to use rule number 3. So take the first number in the product and raise it to the power, and then multiply that by the second number in the product raised to that same power. So 2 to the third power is 8, and then we have to use rule number 5. We're going to multiply those exponents, and so we get 1 over 8 times y to the 15th power. All right? So again, we're just doing more and more practice problems. Okay, so let's try one more of these before you try one of these in the problem set on your own. So now we're going to use rule number 2 because we're dividing powers, so we subtract the exponents. And we get b to the first power raised to the negative 4th power, and then we can use rule number 8. There's more than one way to do this, but I'm just going to do it this way. Actually, no, I'm sorry. We're going to use rule number 5. Raising a power to another power, we just multiply the exponents, and we get b to the negative 4th power. But remember, we can't leave our final answer with a negative exponent, so we have to use rule number 8. And there you go. So I want you to try number 70. You can use numbers 67 through 69 to help you, and when you come back, we'll do it together. All right, we're back. So we have a to the 9 minus 3 times b to the 5 minus 2, all raised to the 4th, and that is rule number 2, dividing powers. And that simplifies to a to the 6th power times b to the 3rd power, and you don't really need a dot in between those. But now we have a product raised to a power, so we're going to use rule number 3. So we take the first number in the product and raise it to the power, and then multiply that by the second number in the product and raise it to the same power. But now we have powers raised to other powers, so we're going to use rule number 5, which tells us to multiply the exponents. So we have a to the 24th power times b to the 12th power. There you go. So if you got that answer, good job. Try number 70, and when you come back, we'll do it together. All right, we're back. So remember, you want to get rid of that negative exponent first, so we're going to use rule number 8 first. So we have 1 over 5x to the 4th power raised to the positive 2 power. So then we use rule number 3. So we're going to raise 5 to the 2nd power and multiply it by x to the 4th raised to the 2nd power. Take the first number in the product, raise it to that power, and then multiply that by the second number in the product raised to that power. 5 to the 2nd power is 25, and we have a power raised to another power, so we're going to have to use rule number 5. So we get 1 over 25x to the 8th power. So if you got that answer, good job. If you make a mistake, that's okay. Just go back and figure out what you did wrong. All right, try number 72, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2 because we have the same base. That tells us to subtract the exponents. Be very careful though, because we have a double negative. So that becomes x to the negative 5 plus 6 raised to the negative 2 power. And let me write that a little better. All right, so now that becomes x to the first power raised to the negative 2 power. Now we're going to use rule number 5, raising powers to other powers. We just multiply the powers, so we get 1 times negative 2. But be careful, we have to use parentheses there because the number on the right is a negative. You can use dots, parentheses, or a cross sign. We're not going to use crosses because we have x's here. We don't want to confuse ourselves. And dots, that's confusing also. So now 1 times negative 2 is negative 2. But the problem is we're not allowed to leave our final answer with a negative exponent. So we use rule number 8 to get our final answer. So if you got that answer, good job. And again, that was rule number 8, that last step. Okay, so the last thing we're going to do today is practice the variation of rule 10. Now remember, for rule 10, it tells us that, that's this bottom row down here, it tells us that a fraction power with a numerator and a denominator in the power, that can be equal to this expression here, or it can be equal to this expression. And what that means ultimately is that these two expressions are equal. So you can go back and forth between those if there's some advantage to doing that. And in the next problems, there is going to be an advantage. So let's do a couple of these so you can see what's going on here. Okay, so we're going to do the inside part first. That's just the easiest way to do it. So we're going to use rule number 2. When dividing powers, you want to subtract the exponents. So you end up with 8 to the 7 minus 3. And 7 minus 3 is 4. And, at this point, we could do 8 to the 4th power and then just cube root that, but 8 to the 4th power is a very, very big number. We want to try to avoid that if we can. So we're going to use rule, it's the variation of rule 10. So I'm going to write a prime there, 10 prime. And we're going to change it so that this power is on the outside. So it becomes cube root of 8 all raised to the 4th power. Now, why did that help us? Well, because now finding the cube root of 8, that's really easy. What number times itself 3 times is equal to 8? Well, that's just going to be 2. So just to be clear, this became that. And 2 to the 4th power, that's just equal to 16. All right. Now that was just a 2-step problem. All right. Some of these are going to be 2 steps. Some of them are going to be 3-step. So let's try another one of those. First, we're going to do the inside part again. We have a power raised to another power, so that's going to be rule number 5. It tells us to multiply the exponents. All right, and be sure that your root goes over the whole expression. A lot of times students don't write the root long enough. You have to write it all the way out here above. And so now we get the 4th root of 81 to the 2nd power. 6 times 1/3 is 2. But the problem is, we don't want to raise 81 to the 2nd power because that number is just really big. It's going to be, it's not going to be easy to do that. So we're going to use the variation of rule 10 to change it to this form. I'm going to take this 2 and put it outside. And why do we do that? Well, because the 4th root of 81, that's fairly easy. May take a little bit of thought, but it's fairly easy. The 4th root of 81, what number times itself 4 times is equal to 81? Well, that's just 3. And then 3 squared is 9. So again, that was Rule 5 and the variation of Rule 10. Okay, so let's try another one here. So we're going to use Rule 6 first to change that 9 to 9 to the first power. Then we're going to use rule number 1 because we're multiplying powers, so we add the exponents. We get 9 to the 1 plus 2, which is obviously 9 cubed. The problem is we don't want to cube 9. That's going to be too big. The number is just going to be too big. So we're going to use the variation of rule 10 to take that 3 power and put it on the outside. Sorry, we keep running out of room here. And then, now we don't have to cube 9, you see. Now we can just find the square root of 9, which is 3. And 3 to the third power is going to be 27. All right. So I want you to try number 76, and you can use numbers 73 through, wait a second, I forgot to write, I'm sorry, I forgot, that was a 3-rule problem. So we use the variation of rule 10. So again, 3 rules on that problem, 2 rules on the previous 3 problems. So I want you to try number 76, use numbers 73 through 75 to help you, and when you come back, we'll do it together. All right, we're back. So we have a power raised to another power, so we're going to use rule 5 first. So that's 27 to the 1/2 power times, or to the 1/2 times 4 power. And then we just get 1/2 times 4 is 2, so we have 27 to the 2nd power. The problem is we don't want to do 27 to the 2nd power because that number is too big. So we're going to use the variation of rule 10 to put that 2 on the outside. And then the cube root of 27, that's really easy. That's just going to be 3. And 3 squared is 9. So again, this part here, that became 3. So if you got that answer, good job. Whoops, I forgot to write all the rules. Sometimes it's easy to forget. I guess that was just a 2-rule problem. All right, try number 77, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 2. We have 25 to the 8 minus 5 power, square root of that. And we get 25 to the 3rd power, square rooted. Problem is we don't want to raise 25 to the 3rd power. It's just too difficult. So we're going to take that power and put it on the outside. And now square root 25 is 5. And 5 cubed is 125. So the variation of rule 10 is really useful in these cases. All right, so if you did that one correctly, good job. I want you to try number 78, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 6. We're going to change that. We're going to change that 16 to 16 to the 1st power. And then we're going to use rule number 1 because we're multiplying powers. We have 16 to the 4th, 16 to the 4 plus 1 power. And then we have the 4th root of 16 to the 5th power. But the problem is 16 to the 5th power, that's too big. We don't want to do that. So we're going to use the variation of rule 10 and take that power and put it on the outside. Okay, and then the 4th root of 16, that's a lot easier to deal with. That's just going to be 2. And 2 to the 5th power That's kind of a big number, but it's manageable. It's just 32. So if you got that answer, good job. I'm going to move these down a little bit. So go ahead and try number 79. And let me write that over to the left a little bit. And when you come back, we'll do it together. All right, we're back. So we're going to use rule number 5 first, raising a power to another power. You just multiply the powers, so we have negative 12 times negative 1/4, and be sure you use parentheses. That's the best way to do it. And so we have square root negative 12 times negative 1/4 is positive 3, so we have 16 to the third power. The problem is 16 to the third power is such a big number. So we're going to take that 3 power and put it on the outside. And square root 16 is 4. And 4 to the third power, we could get rid of the parentheses, but we don't really have time for that. It's not really necessary anyway. Is 64. So if you got that answer right, good job. Now we used Rule 5 and the variation of Rule 10. So I want you to go ahead and try number 80. And when you come back, we'll do it together. All right, we're back. So using Rule 2, we're going to subtract the powers. So we get 81 to the negative third power minus negative 5 power, negative 3 minus negative 5 power. It's all one thing. And then we end up with the 4th root of 81 to the negative 3 plus 5, because it's a double negative. And then we get the 4th root of 81 to the second power. Problem with 81 to the second power is it's too big. The number is just too big. So we're going to take that second power and move it on the outside using the variation of Rule 10. So now we can do it really easily because 4th root of 81, that's just 3. Again, that number may not be exactly obvious, but it's manageable. So now 3 to the second power, that's just going to be 9. So if you got that one right, good job. Okay, so try number 81, and when you come back, we'll do it together. All right, we're back. So we're going to use rule number 1, multiplying powers. We just add the exponents. Whoops. So we have 2 plus 2. And then we end up with the cube root of 27 to the 4th power. The problem is 27 to the 4th power, it's too big. So we're going to move that 4th power on the outside. And now the cube root of 27, that's just 3. And 3 to the 4th power is 81. All right, so if you got that answer right, good job. So we used rule number 1, and we used the variation of Rule 10. All right, good job. So that was the class today. I know that seemed like a lot of work and a lot of tedious repetition, but it's completely necessary for you to learn this material. It's not enough just for you to believe that you know it. You have to know it with fluency. You have to have fluency in the math. You have to know how to read and write it without even thinking about it. So if you want to take screenshots of all the work that we did today, go ahead and do that now to help you with your homework or tests. So this is screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5 and number 6 and number 7 and number 8. But don't go before you get your homework. let's take a look at the homework. So here's the first screenshot for your homework. And screenshot number 2. And screenshot number 3. Remember that homework needs to be complete, correct, neat, and in correct chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're not going to achieve the objective of this course. So get that homework done, and I'll look forward to seeing you in the next class.